All right, if you're watching this video, it's because you were absent last class when we did these three practice problems. These will go into your notebook. These will be part of a notebook check, so let's get started. A proton and an electron are separated by a distance of 5.27 times 10 to the minus 11 meters. If the charge on an electron is negative 1.602 times 10 to the minus 19 coulombs, what is the electrostatic force between the two subatomic particles? And then you have the constant, Coulomb's constant 8.99 times 10 to the 9 newtons per meter. This should be squared times coulombs to the negative 2 or per coulomb squared. So this is the equation you use. F is equal to K, that's that constant, times Q1, charge 1, times Q2, charge 2, divided by the distance between them squared. We can plug in 8.99 E9, this is the value K, times Q1, that's the charge on an electron, negative 1.602, E negative 19, this is Q1, times Q2, that's the charge of a proton, 1.602, E negative 19, note one is negative, the other is positive, divided by R squared, 5.27 E negative 11 squared. When you do this calculation, you get a force of negative 8.31 times 10 to the minus 8 newtons, because that's the unit for force. That's the force, electrostatic force between the two. Oops. So what does the negative mean? This negative sign means attraction, means that this is an attractive force. Easy. Okay, next question, practice 2. All right, we have the same proton and electron, same distance. Now we're given the masses of the proton and the electron. What is the gravitational force of attraction between them? So for this, we use the equation. It's pretty analogous to the electrostatic force. F is equal to big G, where big G is this constant, times M1 times M2 all over R squared. We'll plug in 6.67 E negative 11. This is our big G, times mass 1 could be the mass of the proton, 1.673, times 10 to the minus 27 kilograms. That's M1 times electron mass, 9.11, E negative 31. This is M2, all over 5.27 E negative 11 squared. When you do this calculation, you get a value of 3.66 times 10 to the minus 47 newtons. So that's the force of gravitational attraction. If we compare that to the magnitude of electrostatic attraction, the electrostatic attraction was 8.31 times 10 to the minus 8 newtons. You can see that the electrostatic force is much greater. Force much greater than the gravitational force of attraction. Gravity is the weakest of the forces in the universe. Last question, practice 3. Two charges, particles positive Q and negative Q. I'm going to label these charge 1, this will be charge 2, are placed on the corners of a square as shown. A test charge of negative Q, this is the little baby test charge, is then placed on the corner of the square in between positive Q and negative Q, in between charges 1 and 2. What is the direction of the net force acting on this little Q? So remember, opposites attract and like charges repel. So to see how this is going to play out, we're going to have to draw arrows on here, and I'm going to change my color. Okay, let's see. What is the direction of force acting on this little Q charge because of the positive Q? Opposites attract, so little q would try to move to the left in response to particle 1, so we'll draw an arrow to the left. It would try to move towards the positive q, the big positive q, because these have opposite signs. Okay, and now let's see what's the direction here. That the little q would move because of the big q, the big negative q. I'm calling that particle 2. These have the same overall charge. They're both negatively charged, so they would experience repulsion. Little q would try to move up in response to the charge 2. So overall, the net force is a combination of force 1 and force 2. the net force should be to the left and up. If we do the head to tail method, we have to put the tail of one vector against the head of the other. So what I do is I translate this force 2 over. Translate just means you slide it over. And then you can draw the hypotenuse for this vector triangle. It should be a combination of the two of these. Up and to the left, this is F net. All right, so on the test, if you were to take a test, this question could be on there, and I would have 4 different arrows going in different directions. You would need to choose which is the correct direction, and of course, for this, it would be choice C. All right, that's all I have. Thanks for watching. Make sure to get these practice problems in your notebook and study well.